Hello, good morning, class. Hope you are all doing well. This is another session just to give you an in-depth analysis of what would you will require per Stata going forward. So I just want to take you through some basics in Stata, and these basics will help you to be able to navigate your way around data analysis when it comes to public health. So, um, to start the session, you need to double click your Stata software on your desktop or on your taskbar, and it opens up this window for you. Okay. So once this window is opened, there are two ways, like I said, to bring in data sets. If the data set is um, a Stata dataset, which is a .dta, then we go to the folder here, click on the folder there, then locate that particular word, Stata file. So you see the ones in the deep blue are the Stata files. So once I want to open them, when I double click, it will open. So I want to open Sans Serif. So I navigate myself to Sans Serif and I double click. When I double click, it opens up the data set for me in the variable window, which is labeled here. Now, the data set is opened in my Stata. So the first thing I would like to do is to browse the data set and BR, that is the code to browse the data set and see the kind of data set I have. So this is the kind of data set I have, and look at the way the data is. Those in blue means that they are labeled variables. They are labeled variables. They are labeled variables. Those in black means they are numeric variables. They are numeric variables. They are numeric variables. And those in brown, unfortunately, are categorical but not labeled. Okay? Categorical but not labeled. So when you browse the data set, you will understand the variables thereafter. All right. Now, the next thing that I want us to look at is looking at how to manage the variables that you have in your data set. Remember that I made mention in class that when you take your variable, you can change a numeric variable into a categorical variable. For instance, age. If you have the ages of what we call the respondents in your study that you have captured data on them, you can decide to change the variable age into age groupings by grouping the ages and attaching the frequencies thereafter. So for instance, in this our study, we have age as a what? As a numeric variable. Now we want to change this age into a categorical variable. How do we go about it? So what you do is that you use the command recode. There's a command called recode. So you type recode at the command window. Then go to age and double click age to bring age down. So when I double click age comes down to the command window. Now the next thing I want to do is to issue the command that will cause the age to be converted from the numeric variable to the categorical variable. And what do? I open brackets. Then I tell Stata that it should take the variables from the minimum age and I use forward slash to the age that I want to take it to. So for instance, if I want to take it from if I want to take it from um if I want to take it from the minimum value to 20 years, then I label it as 1 and I give space, open parenthesis, then I put what we call the age brackets there. So I can say less than or equals to what? 20 or less than 21. So I can say less than 21 as the age, first age that I want to look at. The second one I want to look at is from 21 years to 35 years. Then I will use the / again, sorry, to do this. Then I label it as 2. Then I give space and I open parenthesis and I what? Add my age range, 21 to 35 as an age range. Now the next one I want to look at is looking at 36 to 60 years, which I'll label it 3. Then I'll give it the age grouping 36 to 60 years. Now the last one I want to look at is looking at age above 60. So I'll say 61 slash the final number will be the maximum. So we'll use MAX as maximum equals to what? 4. And I give space, open parenthesis, then I write what? 60 years plus. Then I'll bring a comma and pass the sub command generate into brackets age underscore group, close parenthesis, then what? Enter. When I enter that, Stata will what? Create the variable for me and give me the information thereafter. Now, when you scroll down your variable window, you see that a new variable age has been what? Created. Age underscore group has been created. Now we can decide to rename it, or you can decide to label define it or label variable. Okay, to label the variable age and take off the record and say age of respondents in groups. Okay, so you see that once I do that, is age underscore group has changed to age of respondents in groups. Now the next thing I want to do is to check to see whether the groups that I've created are in existence. So I'll use the command tab as the tabulate and go to what? Double click the age underscore group, then I go to enter. When I go to enter, I'll see age of respondents in groups. Now I see less than 21, 21 to 35, 36 to 60, 60 plus. So I'll see the frequencies of each of them within the group. So I'll be able to generate what we call a new variable and labeled it. So now when you go to browse our data set, when you move to the age underscore group, you see that it is labeled in what? Blue. Remember that I told you that when the variable is labeled, Stata shows it as what? Blue. Okay. So now basically that's how to manage our variables. Again, there are other methods of managing our variables in our data set. You might want to drop, you can use the command drop to drop variables. You might want to also drop certain rows in the variable. So you say drop if, then you want put the row there, the row number there. So that is the way to drop variables. You might want to also generate variables. You can say generate Enoch equals dot. It will generate a variable called Enoch in the data set. See it now? It's having Enoch there. Now, we can also decide to drop that Enoch by saying this, then double clicking the Enoch and press enter. Then you see that Enoch has left the data set. So basically, that is how to generate and how to drop variables in Stata. So the next thing I want us to look out for is how to do some descriptive analysis with respect to our data set. Now, if you want to do some descriptive analysis, then you might want to use the command tab for categorical variables, and the numerical variables, you use the command summarize, sum. So if I use tab and I want to check sex, I just come to sex and press enter. So it will give me the frequency of sex for females and males and the percent and the cumulative percentage. Now, if I want to also do tab close, then you see that it has given me frequency for that. So all categorical variables, that's the way we manage them. But number of mosquitoes captured is a numeric variable. So if I want to see the descriptive statistics of that, I'll just say sum, then I bring down the variable most count, then I enter. So you see that it will give you the observations, the mean, the standard deviation, the median, and the what maximum. Now, in other situations, you might want to do extensive statistical summaries around this most count. And what you use is that you use a tab stats. It's a command called tab stat. Then you bring down the mosquito count. Then you say command. Then you say statistics stats into bracket. Then you can now bring all that you want. The total number n. That's the number of number of respondents. You can talk about the mean. You can talk about the median. You can talk about the standard deviation. You can talk about the SE, that's the standard error of the mean. You can talk about the minimum, the maximum. You can talk about the skewness of the data set. You can talk about the ketosis. Okay, remember that these are all measures of central tendency. You can also talk about the percentiles, the interquartile range. You can talk about the fifth percentiles and the likes. So all these are things that we can stand in. I think I have a problem there. Let's take off this. Okay, enter. Yes, so now we have the information of all the statistical summaries with respect to the various commands given. So we have the total number of respondents in the study. We have the mean, we have the 58th percentile, we have the 50th percentile, which is the interquartile range. You have the standard deviation, we have the minimum, we have the maximum, we have the skewness, we have the ketosis. Okay. Now, so let's continue with the analysis. Again, you might want to do what we call cross-tabulation of two variables. When we talk about cross-tabulation is just basically using two variables to look at the intersection of the frequencies of each of the levels of those variables. So what you do is that to do a cross-tabulation of maybe sex and the number of infected with the disease. You want to know per sex the number of people that are infected, male and female. So you can do a cross-tab of that by cross-tabbing sex and infected. So what you do is that you say tab, you use the command tab, then we say sex and also infected. You can use the arrow there to bring down the variable. Then we say comma. When you do this, it will give you the raw count of the of the data of the cross tabulation without any frequency or without any percentages. Now I want to put percentages to them. In putting the percentages to them, you pass a sub command. So you say comma space. Then is it column percentages you want? Is it row percentages you want? You want row percentages. So say row percentage row. Then please enter. When you do that, it will give you the frequencies of those that were infected versus those that were not infected with the condition leishmaniasis. Now, the females, when you look at the total number of people infected, we have 153,051. Then, when you look at the males, the number of people infected is 152,294. Okay, so these are the infected group of people. These are also the non-infected people in the data set. Okay, so that is the way to run a cross tabulation. After running the cross tabulation, if your two variables are all categorical in nature, which is usually the case, to find the crude association between the two of them, that is the test of association. Remember, we mentioned test of association and the crude associations thereafter. So to do that, we just run the same code but add the condition chi2. Okay, chi2, and press enter. Now when you do that, you see that it has added another line of analysis. And the other line of analysis is what? The Pearson chi-squared value, which is this, then the probability value, which is 0.440. So it means that this PR means the probability of significance. So when you take this against 0.05, this one is greater than 0.05. So that means it is not significant. The variable is not significant. So we fail to reject the H naught, and we go ahead with the analysis. So this one means that the sex has no influence on you being infected with leishmaniasis. Okay, so your sex does not matter. Whatever sex you are does not matter. It doesn't predispose you to you getting leishmaniasis in the population. Okay, so that is the way to run the cross tabulation and checking the crude associations in each of them. So again, having done this, the next thing we want to look at is we want to look at for how to be able to manage our numerical variables, So our numerical variables in the data sets that we have collected, at the end of the day, we want to know their how they interrelate with other variables when we talk about the crude associations. Okay, so how do we go about that when your variable is numeric in nature and you want to find out the um, association, the crude association between that particular numeric outcome and the um, the the dependent variable, because in this study, clearly our dependent variable is infected and our independent variables are the other variables that are within the data set. Okay, all these other variables might not be empirically seen as what independent variables, but most of them are seen as independent variables in the study. So we classify them as such. So for the purposes of this class, the number of mosquito counts in the data set will tell us that we want to find out the relationship between that and the infected outcomes of the population. So we want to know the crude association between most count, whether if your mosquito counts in your area are high, it affects your what we call the you being infected with the disease. Okay, so we can use the command. Okay, so to do that, we need to check the normality of the data set that we want to run. So here, in this case, we are looking at the most count, and therefore to do that, you use what we call the histogram, hist, then we bring down the variable most count, then comma, we pass the subcommand frequency what? Normal. So that to draw the frequency normal curve for us. So when you run that, you see that it will run the command and give you the graph. Okay, so this is the graph that we are looking at. You see the normal curve written on it. But because some of us are not statisticians, usually it's difficult to be able to visualize and appreciate the outcome. So we use commands like the SK test, okay, to also check that. Then you bring the variable down, then you press enter. The SK test is the skewness and ketosis test for normality. Remember that when there is skewness and there is ketosis, it means that the data is not normally distributed. So if it's a significant outcome, we say that it is not normally distributed. So in this case, see the probability of the skewness means it's significant because it's less than 0.05. And once that is the case, there is skewness. And also we have the ketosis, which is what's significant. So there's both skewness and ketosis in the data set. So we'll say the data is not normally distributed. So if the data is normally distributed, we use the t-test to check for the crude associations. If the data is not normally distributed, then we use the Mann-Whitney test to do that. So how do you use the Mann-Whitney test to do this right now? You bring the command rank test, rank sum, okay? So rank sum is the command. Then you bring the variable down, which is most count, comma. Then you pass the sub command. The sub command is by what? And by 6. Then we say enter. When you say enter, it will run the probability value for you. So when it runs it for you, you see that this is the what? The Z value, which is 0.178, and this is the probability value, which is 0.8587. So this probability value means that most count and most count and 6. No, sorry, it's not most count and 6. It is by infected, sorry. So when you do that, okay, so now this is the Z value and this is the probability value. The probability value is 0.9067, which is greater than 0.05. Therefore, most count has no influence on somebody getting infected per the crude outcome. Okay, so that's how we test for normality of both the various aspects. Now, the next thing I want to look at is that after being you going through your crude associations, now the next thing you have to do the modeling for the variables that you have in the what in the data set. Okay, so we want to look at what we call what are the factors that contribute to somebody being infected with leishmaniasis. And the leishmaniasis, we do tap to check the leishmaniasis, and we'll say that the leishmaniasis here is what 30% of the population had leishmaniasis, which is 30.80. Okay, so it means that in the population, the about 30% of the population were infected with what the condition. Now, if you want to check the confidence interval for this particular estimate, so you use CI prop, then you bring the infected down. When you do that, it will give you what the confidence interval for what the estimate of the 30.8% that you have had. So you have 30.8% with a confidence level or confidence interval of 30.7 to 30.8. So this is a very closely matched confidence interval showing that the estimate is precise. Look at our standard error here. Our standard error is very small. The smaller the standard error, the more efficient the estimate. So it means that this data set is very robust and it was a good data that we collected with randomization in the population. Okay, so that is it. Now, to run the model, because the outcome variable is binary in nature, which is a yes or a nay, that's presence and absence, usually called dummy variables. The best model to check the factors that are contributing to the infected outcomes is the binary logistics regression. So how do we run the binary logistics regression in Stata? We use the logit command, okay, logit command. Then we'll bring the dependent variable down, then followed by the independent variables, which is what? Sex, then age category, then net use, then treat, then close closeness to the what? The animals to the human beings within the what? The household. So, comma, we use the VCE robust, which I told you about the last time I explained to you. Go to my notes, you'll see it. Then we want to report the OR, the odds ratio for the analysis. Now, remember that sex, age group, net use, close, they are all categorical variables. So what you do is that we put them in a bracket and add I dot for Stata to be able to identify that these are what categorical variables. Then when you do that, you run the model. And when you run the model, it will run the model and give you the outcome. Okay, and it will give you the outcome. Now we have male, sex, age group, net use, close as the variables that we have included in the model. You will realize that under the sex, there are supposed to be two levels. The two levels are female and male. And we are using the female as a comparison group or a base group to the male. So whatever you say about the male, you compare it to the females. That is what we call odds ratio. So odds ratios help us to be able to compare two levels or more than two levels of a variable to the outcome that we are looking at. So here, to interpret this, we need to look at the probability values. You realize that all these figures are what significant because they are all less than 0.05. The cutoff is 0.05, so all of them are less than 0.05. Therefore, these are all significant predictors of being infected with what? Leishmaniasis. Now, we need to interpret what we call the levels of each of the variables compared to its base level to the condition. Okay, so now to compare this, we need to look at the odds ratio. Any odds ratio less than 1 means protective factor. Any odds ratio greater than 1 means exposed. Okay, that group is exposed. Okay, so basically, looking at these, we will say that um, males in the population are less likely to be infected with what leishmaniasis compared to females. So females have a higher chance um, of being infected with the condition compared to males. So this one is subtracted from 1. The figure you get at the end of the day is the figure that is the protective factor for that particular group. Now for age, less than 20 years is the base category. So in interpreting this, you realize that this has what we call a bigger or a higher odds ratio more than 1. So you say that the age group 21 to 35 have a higher odds of being infected with leishmaniasis compared to the category less than what? 20 years. So that is how you interpret the outcome. So we are saying that for the net use, you say those that use net in their houses, LLINs in their houses, has less chance of contracting leishmaniasis compared to those who don't use net in their houses. So you see, that is the way it is. And we are saying that for the closeness to animals, we say that we have those who are living very close to animals have a 2.533 more likely or more chance of being infected with leishmaniasis compared to those who do not live close to animals, which is the base category. So that is the way you interpret the odds ratio. So these are becomes predictive outcomes of leishmaniasis in the population. So your examination will be something similar like this. You need to run these commands to ensure that you are able to get what we call the outcomes needed. And you need to do some data management. You need to do some data analysis with respect to the condition of choice. So a condition will be given to you in a population, and as a public health expert, you are supposed to do what? You are supposed to analyze the data and write a report on the data that you have analyzed. So this is basically the way to interpret your results. Thank you very much, and we will have a session later. Bye.